Okay, so for the next part, we want to find the equation of line L if it is tangent to the graph of f of x at the point 0, 3. So we know to make a tangent line, we are going to need to get a point and a slope. So we already have the point. So our point, it tells us, is 0, 3. So to get our slope, so the slope, it told you, so we have this straight line, so we can find the slope of this line. If you look here at the point 2, 1 is an exact point, and at 0, 3 is an exact point. So if you want to calculate the slope in that, so it's to the right 2, but down 1. So rise over run, so it's going to be -1/2 for our slope. Alright, so once again for the slope, rise over run, so right 2 but down 1, or if you want to think about it as going up 1 to the left 2. Either way, it's going to be a slope of -1/2. Okay, so now that we have our point, now that we have our slope, we can write our tangent line. So it's going to be y minus our y value, which is 3, equals the slope, which is -1/2, times x minus our x value, which is 0. So that can simplify to y minus 3 equals -1/2 x. Or if you want to go ahead and put it in slope-intercept form, this is going to be y equals -1/2 x plus 3. But any of those answers would work there. So we just found the equation, we had the point, we found the slope. Alright, so for the next one it says that what ordered pair other than 0, 3 does the graph of line L intersect f of x? So they're talking about this point right here. So we already know that it intersects at the point x equals 0 or 0, 3. We need to find where it intersects here. So now that we know the equation of our straight line, we can go back to our graph, and instead of y equals 0, we're going to type in our line here. So we're going to have -1/2 x plus 3, and then we can graph this. So now our graph should look like the graph that we had there. Okay, and then this is just a way you can confirm that you have the last part correct. So I want to find this intersection here, so we're going to do second trace 5 for intersect. I'm going to move it close to the point that I want. And then we can hit enter 3 times, and that x value there is 3.390. Okay, so it says at what ordered pair, so we do want the x and y value here. So the ordered pair where they're intersecting is going to be at 3.390, and then the y value there is 1.305. Okay, so we just put the line in y2, and we found where it intersects. Okay, the last part is we want to find the area of region S. So this is the region S. It is bounded by 2 curves. It's bounded by the straight line, and it's bounded by the curve. So if we want to do the area, we're going to make an integral anytime we want to use area. The lower bound, the smallest number where it starts intersecting, is at x equals 0, and then it stops intersecting at this 3.390 that we just found. Okay, the top part of this graph is the straight line. So we know the equation for the straight line is this -1/2 x plus 3. Minus, we always do subtraction, the bottom curve is the curve. So that's from our equation we have here, x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x, and then we always end it with dx. Okay, so we make sure we have top minus bottom. The straight line was on top minus the curve. Started at x value of 0, goes to 3.390. So we're going to use Math 9. So on our calculator, because you already have some of the stuff typed in, here, if you want to go to second entry, you can kind of just edit this. Type all this again. But we're going from 0 to 3.393. To 3.390. And then this time, though, at the front, we have the negative 1/2 x. And then plus 3. And then we're going to subtract. I'm going to put my parentheses here, so we have negative 1/2 x plus 3, subtract. We have our x cubed over 4, minus x squared over 3, minus x over 2, plus 3 cosine x, and then we don't need this minus 0 anymore, so I'm going to get rid of that. And then we should have our dx. Okay, so just know that you can always edit things, so you don't have to keep typing that in. So you should end up with an area of 6.982, and this would be units squared.